substrate or RNA, very short with no structure, and we found that the more structured RNA, the more effective that enzyme is, and when we increase this structural complexity, we can look for more efficient inhibitors. But as I said, we found them very effective in biochemical reaction outside of the cell. That's called in vitro. And then when you start testing them in vivo, only like 20% of them retain efficiency. But then when you calculate how much you have to add to make it a drug, it becomes like, usually we take like 5 to 10 milligrams of some antibiotic per pill, and this one has to be 100. and it's okay if it's not toxic. But when you check what's the therapeutically approved concentration for those, it's like 10 times less. Because people found what's the effective dose and then tested this effective dose for toxicity. When you increase the dose, you have to do a new study for toxicity. And it's expensive, of course, so it has to be really convincing. And since the big companies, the drug, big pharma is not, they still invest in new antibacterials, but not as much as they have to because they don't make so much money. Like NIH, like National Institute of Health, and DITRA, the Department of Threat Reduction, it's like government is taking care to do the basic research. And also DITRA is also investing in the first 2 phases of studies for toxicity and efficiency. So our tax money are used for for our future generation to find something that's effective as antibacterial or antiviral at the same time.
Do you work at all with the CDC, or do they work with you?
No, we don't yet. We're very at the low level of basic research. If we discover something, the sponsor may take care of the further stages of like tests and approvals. But yes, also DITRA is kind of sponsoring those advanced stages when you start doing tests on primates and humans. And then the researcher that started from the beginning, they can participate. But usually those are done by organizations like medical groups, because doctors are involved. Those are kind of not very big pharma, but they're still specialized in this field of approval. They know all the requirements, documentation. And But usually CDC doesn't sponsor this kind of stuff. They're just registering and informing the public what's going on. Yeah, FDA is the one that approves, passes the law.
I did have a question. Do you have any information as far as, for example, using bacteria to fight bacteria? So
yeah, there is also interest in those exotic therapies. The problem is when you have infection and it's in the blood, you don't want bacteremia, so it's not efficient. Also, another way of fighting bacteria are bacterial viruses that are not doing anything to us because they cannot get in our cell, and they have totally different system. But the problem is that they're foreign proteins, and our immune system is attacking them and destroying them even before they get to do their work. And it's the same with bacteria attack. You can do it, for example, on surface, like skin lesions, but you cannot do it inside the body because you're going to activate. Unless this bacteria is totally stripped off of its like antigens, so-called, that it doesn't activate the immune system. And yeah, people try also to cure cancer with those approaches, they still don't have this super bacteria that's like a naked bacteria that doesn't have the sugar and the fatty acids that activate our immune system, but they still have the weapon to kill. So those engineered bacteria are kind of still science fiction, and since they're genetically engineered, you don't know how effective they will be or how dangerous. They will pass even FDA approval more difficult than drugs. In Europe, especially, genetically modified organisms are very, very difficult to pass for anything. But in America, we still have freedom.
My question is related to wine bar, but also perhaps on wise tales. Many of us have allergies. You go in for allergy shots, and they give you some dose that doesn't quite excite the allergy, but somehow builds resistance to it. So, unlike the tannins and the upcoming juniper season that we're faced with, there is some people who claim that gin with a small amount of juniper in it can help build resistance to juniper. What are your thoughts on that?
With the expert in there, I wouldn't even dare. But it's one of the, that's how they develop the cocktail of treatment is adding antigens.
There have been a lot of studies on the oral ingestion of the antigen to see if you can develop the allergy resistance that we get with shots. Turns out that you digest those proteins too well, and you don't get an immunity to them by ingesting them. We are seeing now people putting under the tongue. You get absorption directly under the tongue. Doesn't go through the stomach. Doesn't get the gastric acid. Doesn't get the enzymes that break down proteins. And so we are using some medicines now under the tongue. We can desensitize the tongue, under the tongue. So there's actually a group in Japan because they have juniper allergy, Japanese cedar, and they're working on this. And in the U.S. we've had a couple drugs released for ragweed and dust mite and grass, none of which we have, that you put under the tongue. Now the problem with them is that if you try to desensitize more than one thing at one time, they don't work. But if you're only allergic to juniper, eventually we'll have a tablet that you put under your tongue. But if you swallow it, it won't work. So swish your juniper around.
So instead of injections, can we have stickers like nicotine patches?
Bath and gin?
Not work.
Will it work or not sure?
There are patches work. There's some studies going on for patches, and the allergies going in a couple of weeks. We'll hear what they are for food allergy. Basically for kids that are terribly allergic to peanuts. There's a group in New York that's actually putting a patch of peanut protein on kids and increasing the dose of the patch as time goes along, and they get over their peanut allergy. We don't know yet about the safety of it. And we don't know in the next question the FDA is asking, well, how long does it last? If you stop the patch, does the peanut allergy come back? Does it come back worse than what it was before? So they're having to do a few more studies before it's released. So we're a couple of years away from patches for allergy.
I have a question. Why do so many people in America have allergies?
Oh, people.
It's not
There are
like
so many
everyone
theories
else.
about it. They say hygiene because you're so clean, we are so clean. We wash so much, we brush so much. We kill the bacteria that's not killing us, that's part of our body. So our immune system has nothing to do, starts attacking particles that are not pathogens. So there is still not enough data to prove this one, this theory. But I think allergies are everywhere, even in Africa where kids are running barefoot and exposed to all kind of bacteria and even kids that